is the first step of the Monte Carlo method with fixed steps. The second step is the initiation of the random walk. The random walk is a walker which moves between the grid points randomly. So you need some random numbers. So you start from the point you want. For example, I ask you to compute the temperature of this point. So you will start from this point, and randomly you can go to the neighboring nodes in this grid. But if, for example, the value of the random number is between 0 and 1 over 4, you will go to the right node. If it is greater than 1 over 4 and less than 2 over 4, you will go to the right point, and so on. So based on the magnitude of the random number, you will decide to move or travel from the central point to the neighboring point. This is the random walk process. Generate random numbers, the rule of the game. This is a game. This is an interesting game. We are playing a game. The rule of the game is that you have to start from the node I and j, and if this is the interval of 0 and 1, we always generate random numbers in the range of 0 and 1. It's customary in all random number generators in Fortran or any other programming language. This coefficient here is p sub x plus. I have written p sub x plus here. The second one is p sub x plus p sub y plus. The third one is p sub x plus p sub y plus p sub x minus. As you know, the sum of all of the four coefficients is 1. So the sum of three of them can be written or equals 1 minus p y minus. So if you write this expression, you have to perform two summations. But in this form, you just perform one subtraction. And the last one is 1, which equals the sum of four coefficients. So you have to compute the coefficients from the first step, okay, and then generate random numbers. If the random numbers fall in this interval, you have to move the random walker to the right point, because this is p sub x plus. The node ij goes to I plus 1j. If the random number falls in the second interval, you have to go to the upper node, the third interval to the left node, and the last interval to the I and j minus 1 to the lower node in the grid. This is the rule of the game of the motion of random walker, or the traveling of the random walker between the nodes in the grid, the Monte Carlo grid. Okay, there's one important point here, is that the order of these intervals should be descending. As you see here, descending order. You may pause the video and think about the reason. Why? The greatest coefficient, I mean that the greatest coefficient should be the first one. The reason is that, the Monte Carlo method, the most important problem of the Monte Carlo method is the computational time. So you have to minimize the number of comparisons in the numerical code. So if the greatest interval is the first one, the number of comparison or the number of if statements in the numerical code will be the minimum. Because the probability of falling the random number in this interval, which is the greatest one, is greater than the last one. So you don't need to compare the random number with the other one. So the number of if statements in the numerical code will be reduced. So Okay, and the other point is that this random walk, there is another rule in this game. The first rule was about the process of traveling, or the rule of traveling between points, and the second rule is about the termination of the process. This random walk process which starts from the first node that you want the temperature of that point, will finish when you reach a wall. I will explain about the meaning of wall, but for simply speaking, the wall here is a boundary which you have the value of your unknown function, for example, temperature here on that boundary. This is the wall in this context. So if you reach a grid point on a wall or a grid point with known temperature, you should finish the random walk process and start another random walk from the initial from the first point, and you have to repeat this random walk process for n times, and then at the end of each random walk you save wall temperature. So you have n wall temperatures. In order to compute the temperature of the point ij, you will simply, very simply, sum the wall temperature that you have obtained at the end of n random walks. Sum them, I equals 1 to n. N is the number of the random walks started from the point you want, for example, ij, and ended at walls. This is the temperature of the wall during the random walk number I. And divide the sum of wall temperatures by n, which is the number of random walks. This is you can easily compute the temperature of that point by performing n random walks and just saving the temperature at the end of that random. If you want the temperature of another point, you have to perform n other random walks starting from that point. This is the advantage of the Monte Carlo method. It means that in order to compute the temperature of a point, a particular point, you don't need the temperature of other points.